Good morning, good afternoon, and good evening. Today I'm going to be revisiting this LED bulb that I worked on a few videos ago. I did a modification to reduce the power by about a third. Now there was a side effect that I mentioned at the end of the video that would cause this bulb to flicker momentarily when you turn off the switch. At the time, I didn't know what was going on. Now I am suspecting that it might be the capacitor that is not being discharged. Because if I remember correctly, the circuit board does not include a bleeding resistor on the capacitor. And I'm thinking maybe that's what's causing the flickering to happen. Anyway, so in this video, what I'm going to try to do is to add a resistor to bleed out the capacitor. Alright, I'm going to quickly demo the bulb to show you the flickering that occurs when you remove power. So I'm going to plug in now. There we go. That's my multimeter beeping. And now I'm going to turn off the power and you will notice the flickering. Power off. Okay, that should have been obvious. Alright, so the next step, I'm going to open the bulb up, remove the heat shrink that I have put on the motherboard so that we can get access to the capacitor where I want to install the bleeding resistor. Alright, I'm going to desolder these two wires here and then cut out the heat shrink. Now this is the capacitor that I'm talking about. It's 400 volts, 4.7 microfarad. So that's a microscope view of the capacitor, plus minus leads. And there's the 3R3 that I replaced in the initial video. I'll put a link to that up on the screen at some point. And so there is no bleeding resistor, I mean. Alright, so I'm going to add a 1 mega ohm resistor in parallel to that capacitor. Now, where did I come up with the 1 mega ohm value? Basically from watching a bunch of videos on bigclive.com channel. He has a lot of videos on LED hacking to reduce the power. And in a lot of the diagrams that he shows, the bleeding resistor is almost always 1 mega ohm in value. So I'm going to try that and let's see how well that goes. So I removed this 1 mega ohm resistor from a resistor kit that I have, and we're going to measure it to make sure it's 1 mega ohm. You can see the multimeter up in the top right. Let's see. Yeah, wow, 1 mega ohm, almost spot on. So I'm thinking, let me remove the multimeter, we don't need it anymore. Okay, I'm thinking I'm just gonna solder it to the back of the capacitor. I have access to the 2 points where I can solder the resistor there. Because I checked my SMD resistors and the highest I had is 910K, which probably would work, but I'm gonna go with this quarter watt resistor and let's see how well that goes. Okay, so I think that looks good. I'm going to give it a quick clean, and then we'll do a quick test. Alright, so rather than soldering the ball part and then having to desolder it again when I want to put heat shrink, I just connected it via crocodile clips, and we're gonna test it right now. Hopefully the flickering, when I remove the power, the flickering will be gone. I'm gonna stand a bit far because I haven't tested this yet. Plugging in 3, 2, 1. Okay, that's a good start. Nothing blew up. Not yet, anyway. Okay, and now the big test. Let me hold it like this so we can see if it's gonna flicker. I'm removing power now. Okay, so it's still flickered. That resistor made no difference. Alright, so I also tried a 470 kilo ohm resistor just to see if it makes a difference, and it didn't. It was still flickering. So unfortunately I'm gonna have to give up on this, just to quickly show you that the bulb actually still works. There we go, and still flickers. Yeah, I have removed all resistors. It's back to what it was before. Anyway, I enjoyed doing this project even though it didn't end successfully.
Or did it?
Well, hello again. It's been many hours since I finished this video, but let me show you what we have now, and I'll explain after. So the lamp is still turning on. Now I'm going to disconnect the power. Now, no flickering. Once again, disconnect now, and there's no flickering. Let's go quickly under the microscope and let me explain what I did. This is the 3R3 resistor that I put in the original video, and that caused the flickering to start. Then at the beginning of this video I tried putting a bleeding resistor on this capacitor, and that did nothing, so I removed it. This is the quick recap. So then I kept reading in the data sheet of the main IC, this IC here. And so pin number 4 on this IC is something called the LED open voltage. And so I looked at it, and the formula for that actually includes the value of this current sense resistor, but it includes it as a divisor. So meaning if we increase this 3 folds, I was thinking that if I reduce this 3 folds, then it will solve the problem. And that's exactly what happened. So the original value here was 62K. Actually, I still have the resistor right here. Let me just, I'm going to pick it up. There we go. Yeah, let me focus a bit. It's 62 and 3 zeros. So it was 62K. And so divide that by 3 and you get about 21K. And I came across 22K, so I used that. As you can see, 2, 2, 3. So that's 2, 2, and 3 zeros, 22K. And that pretty much is what got this working. And so now basically I know that anytime I change the current sense resistor value, I need to also change this, I think it's labeled ROVP pin. I need to change the resistor on that pin accordingly. It's really satisfying to get this working finally. I tried so many different things, but really the answer was finally in the data sheet. And just understanding what that ROVP pin was really solved the issue. So here we go, last quick demo and unplugging, no flickering. Anyway, I hope you enjoyed this video as much as I have, and see you on the next one. Bye bye.